Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will take a graph and be able to sketch the graph of its derivative. So here, we're going to let this graph be a displacement graph and sketch the velocity and acceleration graphs. It doesn't actually matter what this graph represents because all you need to know is that if xt is the displacement graph, x dash t, the derivative, will be velocity, and the second derivative will be acceleration. So really, all we're asked to do is take this function and sketch the graph of its derivative and also its second derivative. Now, for some reason, xt usually represents displacement, so here x is along the vertical axis and t for time is along the horizontal axis. So just be aware of that. So we're going to start by graphing this, the velocity function, which is just the graph of the derivative of this function. So, firstly, to draw the derivative graph, note that this is a parabola. So hopefully you know by now, if you differentiate a quadratic function whose graph is a parabola, you get a linear function. So the derivative graph down here should be a straight line. So we're just going to look at where this line would be positive, would have a positive value above the axis, and when it would be negative. So firstly, what we can see is there is a turning point of the function at x equals 6. So when there's a turning point, the derivative is 0 because the derivative is the gradient. So down here, this function would be 0 at t equals 6. Now what's happening here is that the function is increasing. There is a positive gradient between 0 and 6. So that means the line will be positive between 0 and 6. It will be above the t-axis here. What happens, though, is it's sort of slowing down. It's increasing at a decreasing rate. So what will happen is the line will look like this. So that's in the domain 0 to 6. So it's positive gradient here. So that's why this line is positive. It's above the t-axis, but it is decreasing. So that's why it's going down. And then it will hit the t-axis at x equals 6, which is the stationary point. And then it will just keep going and become negative because the gradient of this function is negative after t equals 6. So the gradient being negative, that's why this straight line is below the axis. It is negative. So that is what the function will look like. This is the derivative function x dash t, which in this example happens to represent velocity. So let's now sketch the acceleration. So the acceleration graph is the second derivative. It's just the graph of the derivative of this function. So, hopefully you know by now when you differentiate a linear function, you just get a constant. So the acceleration graph is just going to be either up here, straight line, or a straight line, say, down here. Which one will it be? Well, we can see clearly that this line here has a negative gradient. It's leaning to the left. That was because this function, its gradient is decreasing all the time. So that means because the gradient of this will always be negative, it will be a constant negative function. So it will just be some negative value down here. That's what the acceleration will look like. All right, let's look at a more complicated displacement function now. So this time, I've given you a cubic graph. So if this graph represents displacement, the change in y with respect to the change in x, then its derivative graph will be velocity, and its second derivative graph will be acceleration. So all I'm going to do is draw the graph of the derivative of this function, and then the second derivative of this function. So hopefully you know by now the derivative of a cubic is a quadratic. So let's start by finding out where this quadratic would hit the x-axis. So to do that, we find the turning point. So they are at 5 and 12. So the reason that the quadratic would hit the x-axis at this point, at 5, x equals 5, and x equals 12, the gradient of this function is equal to 0. So that means that the quadratic, which is the gradient function, will be 0 at these 2 points. So it will pass through these 2 points. So let's look at whether the gradient is increasing or decreasing. So over here before 5, the gradient is decreasing. As x is increasing, y is going down. So that means the gradient will be negative before x equals 5. So that means that our parabola over here will be below the x-axis before x equals 5. Then the gradient is increasing between 5 and 12. Again, increasing at a decreasing rate. So that means the parabola will be above the x-axis between 5 and 12. And after this stationary point, the gradient is again decreasing. So the quadratic will be negative again after x equals 12. So hopefully you see that the quadratic will look like this. So this says exactly what I just said, that this function is decreasing, so the gradient is negative before x equals 5, then it hits the stationary point, then the gradient is increasing at a decreasing rate between 5 and 12. So that's why the parabola is positive between 5 and 12, because this function is increasing between 5 and 12. And then after x equals 12, the gradient is negative because the function is decreasing. So this is the graph of the derivative. So if this graph here represented displacement, this would represent velocity. So what about the acceleration graph? So you would remember the derivative of a parabola is a straight line. So this parabola would be a maximum, as all parabolas are, halfway between the two x-intercepts. So the stationary point of this parabola would occur at 8.5. So that means our linear function would be 0 at 8.5. So it would go through this point here. We just don't know yet, does it go this direction or this direction? So the parabola is increasing before x equals 8.5 and then decreasing after x is 8.5. So it will be positive before x equals 8.5 and then negative afterwards. So it'll look like this. So a straight line with negative gradient that goes through 8.5. Once again, the gradient of this line is negative because for this function, the gradient is always decreasing. The gradient's decreasing, it's positive gradient before 8.5 and a negative gradient afterwards. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.